Today, ladies and gentlemen, what we are going to be talking about is something called the composition of functions. So we did all the other operations, add, subtract, multiply, and divide. Composition of functions is when you essentially plug one function into the other function. Okay? Something I want you to be very clear with. In between the F and the G, see how that's an open circle as compared to the little dot that means multiplication? So just a dot is multiplication. The open circle means composition. Okay, two different ways of writing it. I prefer writing it this way, read as F of G of X. I like writing it this way for two reasons. One, you don't mix up that it's a multiplication problem. Okay, and number two, it kind of shows you what you need to do. So for example, in F of G of X, what it's saying is, see how the G's inside? You're plugging the G inside of the F. And I feel like that is a better representation of what it's telling me to do. That's why I typically write it this way. But I want you to be able to read it and write it that way as well. So here's your example. If F of X is X squared, and G of X is X plus 1, and they want you to find F of G of X. G's in the middle, right? So G is your plug-in. So what it's basically telling you to do is plug G into F. So instead of G of X, that was X plus 1. So I'm plugging F plus 1 into the F function, and that's how you pop out with that answer. Okay? That's what it means. So let's try. All right, the first one, F of G of X. I'm giving you two different functions. I could rewrite this as F of G of X. I like to see which one's in the middle. So really what I want to do is find F of my G function. My G function is 4 minus X squared. So all I'm doing is replacing my G of X with what it is. When I see it like that, that means that is what I'm plugging into F. So anywhere you see an X, that gets plugged in. So if your function is this, right? This is your X. That's where you plug it in at. So I'm going to leave a big gaping hole, plus 2. This is my F function, X plus 2. What am I filling in for the X?
4 minus X squared.
4 minus X squared. And then you're just going to combine your like terms. So my final answer would be, right. Okay, either negative X squared plus 6 or 6 minus X squared. That's it. Okay?
Let's take a function with any function.
Now, the next one says F of G of 2. Two ways to solve it. Right. We already know what F of G is. We can plug 2 right in. I'm just going to do that over here. So 6 minus 2 squared, which is 6 minus 4, which is 2. Say you didn't do this step already. Okay? What this would be asking you to do is find F of G of 2. So my innermost is the G of 2. How do you find G of 2? Plug 2 in, right?
Yeah.
So it'd be 4 minus 2 squared, which is essentially 0. Okay, and then it's telling me I want F of that answer. So F of 0 then is 0 plus 2, which equals 2. So see how you get the same answer either way?
Oh, so do you plug in the answer into F of X?
Mm-hmm. Yeah. So in this case, I plugged my function in to F. Okay, so I took this whole thing and I plugged it in where I saw that X. In the second situation, it says I want to plug 2 into the G function. I'm going to get that answer, and I'm going to plug that answer into the F function. Now for part C, you can see I did G of F of X. Why would I do that? Kind of. Do you think that they would be the same thing? No. Could they be the same thing?
Yeah.
Yeah. But they do not have to be the same thing. So let's find G of F of X. So that means this time I'm looking for G of F of X. So F of X is X plus 2. So I'm going to plug that into my G function. So it's x,
4 minus x plus
4 minus x plus 2 squared, which means what do I have to do with that piece?
2.
FOIL it. So we're really going to do x plus 2 minus x plus 2. Alright, so that's going to give me 4 minus, and I'm going to put a big bracket there so I remember to subtract everything. So it's x squared plus 4x plus 4. Okay, and everything's getting subtracted, so what would my final answer be?
Wait, what?
Yes.
Why is x plus 2 being plugged into g?
Because
Oh,
it's
because f of
g of f of x, so f of x is in the middle this time. F of x is x plus 2.
And then you put
So that's going to go into g. Okay, so g was 4 minus x. So 4 minus x plus 2 squared, because that's what I'm plugging in. 4 minus x squared. Okay, then I had to FOIL it, and then I had to subtract everything. So now when I want to find g of f of 2, I can plug 2 right into here to get negative 2 squared minus 4 times 2,
Negative 4.
which is negative 4 minus 8, which is negative 12. Good. Okay, and again, just because I'm going to show you the other way, g of f of 2. That means I start in the middle with f of 2. That's a sad-looking parenthesis. F of 2, okay, would be 2 plus 2, which is 4. So then I would look for g of 4. So that's 4 minus 4 squared, which is 4 minus 16, which gives me... Why am I one?
Wait, but you have to.
Yes, thank you.
wait, when a number's squared, it turns positive.
In this case, it's x that's squared with a negative in front of it. I only plugged in 2, so I'm squaring the 2 and then popping the negative in front of it. The square is not in the parentheses, or the negative is not in the square. Alright, so that's how that works.
I still don't remember the second x plus 2 times squared.
Because I'm doing x plus 2 times x plus 2, so I wrote it there so we can FOIL.
Oh, because the 2x. Okay, I got you.
Alright. Let's go to the next one. Alright, I give you 2 different functions. Let's do this again. F of g of x. So for this one, f of g of x. Okay, so I'm looking for f of 4x plus 1. So this time I'm plugging in the 4x plus 1. So I'm going to take this and plug it right into here. All right, so that's 1/4 times 4x plus 1 plus my 1.
Minus 1.
Oh, thank you.
That's really.
Which gives you 1/4 times 4x, which gives you x. Huh, that's pretty.
What about the. Oh. Okay,
So then what would f of g of 2 be? 2. Okay, and again, you can plug them in individually to the f, or to the g, right? So that would be 4 times 2 is 8 plus 1 is 9. And then if you plug 9 in here, 9 minus 1 is 8 times 1/4 is 2.
So what
Yes.
would be quicker, solving it x and then plugging the number in, or just doing it with the number?
I think plugging the number in is faster because then you don't have to worry about any foiling or like big multiplying of polynomials. So in a lot of cases, that's going to be faster. All right, letter C. This time I want it the other direction, g of f of x. So g of f of x.
So do you FOIL the 1/4?
Okay, so then this is going to give me g of x minus 1. All right, so that's going to give me 4 times 1/4 times x minus 1, right?
So just equals x.
X plus 2.
Right. Plus 1.
So could you just Could you distribute the 1/4 before you
Yeah.
plug it in to make
Wait.
it easier?
Yeah.
What if you just cancel out?
Plus one.
Plus 1, right? So when you distribute in, they cancel each other out, and you're left with x minus 1 plus 1, which gives you x.
That is
Oh, nice.
so.
So what do you think?
It's not that bad.
We get the same answer no matter what the closure you use.
Well, the ones above, did you get the same answer when you composed it both ways? No. This time, though, what did I get each time? X. What do you think that means?
Oh, really?
They're the same.
Let's go back and look. Let's go back. What are the equations we worked with? What do you notice about those equations?
They're opposites.
They have the same number.
Opposites, and there's no fraction.
They're kind of opposites. What do you mean by opposites? They're not conjugates
The one coefficient is reciprocal
of the other one, right?
And then
They are
And then the one is a plus one, the one is minus one. The word that you're looking for, which is in our next section, they're inverses of one another. They are functional inverses of one another. And that's what we're going to do in section 1.7. So there was a little prelude to the next section. So it does mean something special. All right, next one. Now I want to throw domain back into the mix. I told you we're going to do domain for the rest of your life. All right, so my function x is square root of x plus 3, and my function g is x over 2. We want to find the domain of f, g, and f of g. So basically, we're kind of investigating how the domain works with composure. So, what would be my domain of f?
Yeah. So it'd be like all of them.
No. F is a square root function. What's not allowed to be under the square root? Negative numbers. So solve it. X plus 3 has to be a positive number or 0. So x would have to be
Greater than negative 3.
right, greater than or equal to negative 3. How do you write that in interval notation?
Negative 3 comma infinity.
Negative 3 comma infinity and
Inclusion.
okay, so there's my domain for f. Let's do my domain for g. What is it? All reals. That's an easy one. All right. So now I need my domain for f of g. What do you guys think?
Would it just be
Negative infinity to negative 3, and negative 3 to infinity.
So you're saying everything but negative 3.
But that could work for the.
Well,
Would it be negative 3 comma infinity?
say it again.
No, it's just.
Where are you coming up with that? Okay, so you're looking for actually what f of g of x is. Okay, let's do that. So f of x over 2, right, is going to give me the square root of plus 3, okay. So, right, plus 3 would have to be bigger than or equal to 0, right? So then x over 2 would have to be bigger than or equal to negative 3, and that's where you got the negative 6 from. Okay, so x has to be bigger than or equal to negative 6. Now, here's what we need to think about. We create this. If you look at just this composition, this would be what it is. X has to be bigger than or equal to negative 6. Agree with me? Okay. This, though, came from 2 other functions, so we have to think about that as well. What function did we plug in first? The g function. We plugged the g function in. Did my g function have any restriction?
No.
No.
No, it did not. Okay, so are there any added restrictions we need to think about?
No.
No. So then what do you think the final domain would be?
All real numbers.
It would be what we found.
Oh.
Everything has to be bigger than -6. And we can include -6. Nothing happened because what we plugged in had no kind of a restriction. All right, let's look at the next one, because obviously something else might happen. All right, next problem. There's my F, there's my G, and I want to do all my domains. So, what is my domain of F this time? Everything but
And negative.
and -1. All right, so how would I write that? Negative infinity to
-1 not
1
included
in union with
-1 to 1 not included.
1. Good.
1 to infinity.
All right, there's my domain.
What?
A lot of numbers.
Yeah.
A long way of writing cannot be equal to plus or minus 1. All right. What about my domain for J?
And then domain of
Domain of the composition. Before we find the domain of the composition, what do we have to do?
composition.
Compose it. All right. So I'm plugging G into F. So F of x plus 1 is going to give me 3 over x plus 1 squared minus 1, which is going to give me 3 over x squared plus 2x plus 1 minus 1, which leaves you with,
3 over x squared plus 2.
okay. So what doesn't work here? X cannot be
0.
0 or -2. So what would be my domain of f of g? Okay. Now you're like, not getting this point here.
I see. This is gonna get rid of
Not getting this point here. Okay, again, this is because I had no restrictions on the G. Yes, Reese?
Do you multiply the restriction by 2?
No.
Here
We
we
just did it from
subtracted
down
one.
here.
Here we
The reason why the F1 isn't really the domain of F, I keep asking you about the domain of G, but I don't re-ask you about the domain of F because we're never really using the F function in the end, right? Okay, we are using the G to plug it in, but the F is being manipulated. So that's why that changes. All right, let's look at
Let's
this one. Aha! G is not all reals this time. Okay, so what's my domain of F?
negative
All reals, okay. And what is my domain of G?
0
Okay. 0 to infinity. Okay. So now I need my domain of f of g of x. So my composition over here would be f of the square root of x, which is going to give me square root of x squared plus 1, which just gives me
x plus 1.
actually no, not x plus 1.
Why is it not?
Absolute value x plus 1. Okay. But what is my domain for this?
0 common.
All reals, right? If I'm looking at this right here, it's all reals. However, what do we have to plug in first? This. So what would be my final domain for my function?
0 to infinity.
0. All right, and that's why you have to look at it. So let me try and give it to you in a non-math format. Okay, so what if I said the g function is all the girls in the room? Okay, the g function is all the girls in the room. The f function would be people who fish. You see, I have a letter thing going here. Okay, so the G function is all the girls in the room, and the F function is all the people who fish. What would the composition of the F of G of X be?
Girls who fish.
Okay, girls who fish. Notice, did you say any boys?
No,
No, why not?
because they're
Boys
not
aren't
girls.
girls.
Right, because originally we're picking all the girls, and then out of those girls, we want the girls who fish.
So it's like an
So the boys
and.
didn't even matter because they were not in the original
Like an and
domain.
clause.
Does that make sense?
It's like an and clause.
Kinda, yeah.
It's like
Yeah.
And clause.
Yeah, kinda like that. All right, so do you understand why that function domain is important?
Yes.
Because if it couldn't get plugged into the G, then it can't get plugged into the composition because it wasn't there to begin with.
Sans.
Okay? And then obviously, if I started going the other direction and I did G of F of X, then it would be the other way around. Okay, then it would be people who fish, and then out of those people, it would be the girls that fish.
Because girls are better than boys.
I picked G for girls and F for fish.
Sure.
Female.
All right, questions? All right, now let's talk about decomposing a function. So we put the functions together, now let's decompose them.
It's like, no.
So I want you to write this function as a composition of two different functions. So I'm giving you the H function. I put two functions together. Tell me what F could be and what G could be.
That could be
And we'll
on.
just say our inner is going to be the G, and our outer will be the F, just because that's kind of what we've been working with. So what could you call the G function here and the F function here?
So,
Okay, F would be x cubed.
3x minus 5.
Yep, that's a great answer. Because you take the original function, 3x minus 5, and you cube it. Good. Would anybody do it differently? That's the way I would probably do it too. For some of these, there's more than one answer. All right, let's do this one. What would you like to be the G function?
X minus 2.
X minus 2,
And the other one.
and what would we like?
and then f of x, you want to be
1 over x squared.
1 over x
What
squared.
base?
Couldn't you also do, as another option just because,
Solve it.
couldn't I make my G function x minus 2 squared? And couldn't I make my f of x function
1 over x.
1 over x?
Yeah.
Yeah. Is one better than the other? No, they are both options. Do I have any questions?
Vertical.
Okay. And you have your textbook problems. Go.
You're right.
Can we